Hey, good morning, Pirates. This is a description of our agenda for Tuesday, March 2nd and Wednesday, March 3rd. And our objective is to use data to support and verify the concepts expressed by Newton's second law of motion. And today we're going to start with our bell work. And in our bell work, you're going to copy these two images into your bell work and then use arrows and text boxes to kind of tell a story related to Newton's second law. And I'm going to do that with you. And part of the goal is getting you used to using arrows as vectors to show forces and marking up a diagram. And the arrows become your data to use in your description of Newton's second law's application. So take screenshots of those and then paste them into your slideshow. Command Shift 4 gets you a screenshot. I'm going to do both of them. Command Shift 4, Command Shift 4. Then I'm going to go to my bell work and I'm going to insert those two images. There's one. There's the second one. And I'm going to put them side by side, but leave a little bit of space. And then using arrows, you're going to add these details to each one. And so the force to the right and the left on this first one is the same. And the force by Sam pushing on the fridge is equal to 40 newtons, and the force of friction is equal to 40. And the mass of the fridge is 91 kilograms. So to do that, I'm going to add these two red arrows and try to make them identical. So arrow with a line in this direction. While it's highlighted, I want to change the weight of it so it stands out, and notice the arrow gets bigger, and the color of it. And then I'm going to do the same thing on the other side. Try to make them the exact same length because in this case you want them to cancel each other out. Then I just make little text boxes, and in the text box I'm going to describe the magnitude of the force. And then if we apply Newton's second law to this first scenario, the forces cancel each other out. There's no net force, no movement. The mass of the fridge is constant. And so you're going to do the same thing with this second diagram. Notice that in this situation we have a force from Sam pushing on the fridge of 100 newtons and still 40 newtons of sliding friction. So we will have a 60 Newton force going to the right. And to calculate the acceleration of the fridge, we would use our Newton's second law and create a description below showing that. When you're done with that, submit your slides for the day, and move on to number 2 is just use this key to check your work from Monday and last Friday on Newton's second law problems, and then edit your paper if there's a need, and reflect, is there some part of this that you misunderstood? Did you remember to convert your grams to kilograms and so forth? And ask if you have any questions. Your next opportunity to demonstrate this will be a graded quiz over Newton's second law. Today's activity is called Forces in Motion PhET Simulator Activity, and this is a simulator. So the very first thing is open this Google Cloud assignment, and you'll see that the very first part is just play with the simulator. The simulator is linked right here. Once again, make sure you zoom in to 100% so you can see. Open the simulator by clicking here. It's going to ask you to play with the friction screen first. So the friction screen is right here. Double click and open it. Move my camera out of the way. I would check all these boxes so you can kind of see all the factors. Notice there's a pause and a play button. You can hit pause, set the force in one direction. You can see the arrows showing the sum of forces or net force, applied force, and the friction force, and the mass of the crate. You can also add to the mass of the crate by moving these little manipulatives. And then you can hit play, and you can see it's canceled out here. If I remove some mass, start moving. If I remove even more mass, I'm moving faster. I can increase friction, decrease friction, and notice it's giving you a speed. So play with that a little bit, and then play with the other parts of the simulator, the motion and net force. Once you're familiar with the simulator, if you go back and follow the directions using the simulator, you're going to do specific things and then type your answers of your observations in the appropriate text box. When you get all done, go back to the assignment and submit it. Let me know if you have any questions. I will have the Zoom open all day once again. Hope you have a good day. We'll see you on Thursday. Bye.